Alrighty, up and running again, and I think this is a pretty important video because it's going to launch us into some explorations. And let's see if I can get squared up. Some explanations need to be given so that we can launch ourselves into rewriting all of these exponential functions in the same notation. All right, and my experience has been that looking at that topic takes a long period of time to really understand what's going on. So we want to start the discussion here about getting good at writing exponential functions, being able to sketch their inverses, and then looking at the inverses and being able to write those equations as well. And with good sufficient practice and understanding that process, then we can rewrite all exponential functions, not just the doubling every 10 years or cutting functions, quantities in half and quantities in half every 10 years and tripling and, you know, a third of this, a third of this, a third of this, that kind of thought process. We're going to write it in this all in the same base. And that's going to take, I think, a little bit of really understanding this process, which means we got to practice it. All right, and it's not something new. It's been on homeworks already this year, but we're doing it again. All right, so I'll get some quantities here. And just out of curiosity to see where you're at, what do you think the base of this exponential function is? Well, it's a ratio of change. And I tried to draw something that looked like it was maybe a 3-to-1 ratio of change. So if I put some numbers in here, and of course that happens every 97 years. Okay, so we're starting the discussion here. So how much do we want to go up by? Let's go up by 4 units, and then this is up by 12. All right, so 10 plus 4 is 14. You have to measure from a particular initial quantity, perhaps. I'm not quite sure how I want to describe that in a physical context. 10 plus 12 is 22. And these won't be given. All right, you have to find them. You have to find those differentials we call them. And the second differential, the difference from 22 to 10, divided by the difference of 14 to 10, will serve as our base. So what's this equation? Well, everything's above 10. First one is 4 units above 10. Next time it's not 4, it's 12. And there's our tripling function. And our first time is going to act like a 0, so 1903. We should throw a 1903 in here right now for the time. 1903 minus 1903 is 0. Anything to the 0 is 1. So you get an initial change with 4 units on top of 10, takes you to 14. And then, just like you're doing with linear functions, you're looking at the change in x, which is 97 years. So that when you put in 2000 minus 1903, you get 97 divided by 97, which is the number 1. Raising something to the 1 gets you what's in the parentheses, which happens to be a 3. And 3 times 4 is 12, plus 10 is 22. That should mean more to you now than it did a week or 2 ago. Because we actually have been, not everybody, you know, some people are not looking at this a little bit every day, and I strongly suggest you start. It doesn't take more than a minute or 2 to do one of these problems. And then over time, usually about 4 days, it starts to make some sense. So now we want to graph the inverse. Okay, and you can graph the inverse from what you're looking at. So what's the inverse? Well, let's actually, I did a drawing here. Right, I think. Yeah, you're looking at exponential growth, something similar to what's on the board. And if you switch the x's and the y's, instead of x to y, y to x, you get a picture that looks like that. So, instead of a horizontal asymptote, you get a vertical. Understanding what that represents is going to take time, but it's x equals 10. Instead of vertical differentials, you're going to get horizontal differentials, and you're still going to get a 3-to-1 ratio. So I'll just draw a 3-to-1 ratio in, and you're going to get, instead of 1903 to 14, you're going to get 14 to 1903. And instead of 2022, you're gonna get 22 to 2000. That's the inverse. I hope you can see that from 10 to 14 is actually 4, and from 10 to 22 is actually 12. So there is some, similarity here. That's word, huh? Then the question is, what if you didn't have this? All you had was this equation. Well, the first thing you have to ask yourself is, what's the inverse of exponentiation? Okay, and we're still trying to learn that. It's been a couple of weeks, but every day we say the answer to that question. The inverse of exponentiation is logs. Right? Instead of using an exponent to get a quantity, we're given the quantity, we're trying to find the exponent. Right, over here, 1903. What was 1903? It's in the exponential position. Here it's in the quantity position. And when we write y equals, let's start with the quantities we see. I see 1903. And then from 1903 to 2000 is a change of 97. And it's a logarithm, and I'm going to use capital L, so it doesn't look like an I or a 1. So it's a log. And logarithms have domain restrictions, which means there's only certain x's on the board, and all those x's happen to be bigger than 10. Right? And you can't log anything but positive numbers. So where are the positives? They're bigger than 10. And writing x minus 10 measures things from 10. So the question is, what's the x I'm going to use next? 14. And 14 minus 10 is 4, but 4 divided by 4 is 1. And I don't care what the base is. You want to know what log 1 is. And that's asking the question, regardless of the base, what's the exponent you put on top of a base to get a 1? And I hope you say 0. Because what's the easiest multiplier? 0. And then we're multiplying 0 times 97, which is 0 plus 1903. Gives us a correlation of 14, gets us 1903. And looking at the parentheses, this has to be positive. X minus 10 over 4 has to be positive. Greater than 0. So multiplied by 4 and add 10. Then you got to be bigger than 10. That nails the asymptote. So the last thing we have to do is get the base of this function. And you get that by using your second x. So you put 22 in. What's 22 minus 10? 12 divided by 4. There's your base 3. That's what we want to learn how to do. So we're going to do an exponential. We're going to change it into an inverse. And then we're going to learn how to write the graph of that inverse. And that process is very important to understand, because we're going to change all of these things into a new notation. All new notation. One that the world works with when studying exponential change and its inverse. So that's problem 1. Let's try problem 2. Not only is there exponential growth, but there's exponential decay. So I'll do one that, no, I think we'll stick with growth for a while, because this conversation is going to change a little bit when we do decay. And that might throw you for a loop for a while. Can't help that. You still have to talk about it until your brain can process it. All right, so let's see. Should I do a random one? Yeah, let's just do a random one. Right? Not necessarily a doubling or a tripling, but let's do another exponential growth. Let's say that y equals 4. Let's do something random. Let's go 2023. Last year there were 9. And over here, let's go with 2050, projecting into the future. There will be 21. Right? Just random numbers. Right? You're pausing the video and you're trying to write that equation. I'll just continue. Y equals 4. How do I get from 4 to 9? I gotta go up 5. The next time I don't go up 5. 4 to 21 is 17. So it's a little more than tripling every what? 27 years. That's the change from 2023 to 2050. And I want to make a 0 out of 2023. So x minus 2023. Hoping that some of you are actually getting quicker at that. Let's bring this camera a little bit closer. All right, now you're gonna graph the inverse. I'll try to draw it a little smaller so we have some area to work with here. Okay, and then of course we want to know some new values without a calculator, and that's coming down the road too. But what's the inverse of y equals 4? X equals 4. What's the inverse of 2023? 9 comma 2023. Put a little dot there. What's the inverse of 2050? 21 comma 2050. Okay, that's there. So we've got an exponential function. There's the inverse. Now you're pausing the video and you're trying to recall what we did 3 minutes ago. Y equals, well, let's start with a Y. 2023. How do you get from 2023 to 2050? It's like add 27, it's a log. Just use L this time, not capital. Right? It has an asymptote of x equals 4, which means all of our x's. I mean, I can draw it on the other side, but that's another topic. X equals 4, so I'm going to say x minus 4. I'm going to use my first x, which is a 9. 9 minus 4 is 5. And then I'm going to use a 21. 21 minus 4, 17 fifths. And you compare the two. And yet, part of studying math is looking at something with a critical eye, trying to see the patterns. So if you want to make some gains here, you got to look at it a little bit. Certainly has the same base. Now, how would we get that without this? And without this? Well, we'd have to do what? We'd have to pretend we had an answer to an equation. We'd have to do the inverse operations. So what's the first inverse operation? We're calling this now f of x. Right? You just had a quiz on this. We're calling this f minus 1 of x. So let's get a little practice here. All right, and so we're taking the answers to these equations. We'll call it a for now, and then we'll change that to an x later. Well, I hope you take away 4. Maybe I gotta move that a little further to the side. Our answers, I think we take 4 away from an answer. You know, like if we set this equation to 21, right? We set it to 21, right? To try to solve for 2050. Well, we take away 4. Then I think you're dividing by 5. Okay, if I make this an x now, a calculation based on the answers. So that takes care of that, that takes care of that. I think the inverse of exponentiation, oh, that was stated 5 minutes ago, is logarithms. So that's 17 over 5. That's the base. And this should be in parentheses. Now we have division by 27. I think that's multiplication by 27. And subtraction of 23 is addition to 23, and I'll put it at the end. Well, we had a minute ago. Okay, so that's 2. Maybe we'll just do one more. And I'm going to stick with growth. Decay. If I did decay, it would, I'd have to change a plus and a minus, and I don't want to do that to you right now. So there's exponential decay, yes, something that decays, and if I switch the x's and the y's, doesn't look quite the same as the inverse growth. It's got an asymptote, x equals, but that's the shape that you would get. Maybe I should do one, I don't know. We'll do one more growth. Let's stay right there. Then I'll do one for you in class and you can ask questions. We'll do a decay in class. All right, so let's just do one more. Let's have this conversation one more time. Random numbers. Asymptote of y equals 3. I'll do a canned problem. Let's do a doubling. So let's say that in 1990, we had 10 of something, and I'll double. So that's that distance, and doubling it. Doubling it would be about here. That would be a doubling every what? 1990 to 2023. Well, that's 2024. All right, so that's 34 years elapsed time. And from 3 to 10 is a differential of 7. So I want a differential of 14. Maybe it would be helpful to show you that. 7, 14. Okay, and 14 plus 3 is 17. All right, so y equals 3. Right, all of our y values are what? Above it, we'll read from left to right. So 3 to 10 is change of 7, next one's not a change of 7, 3 to 17 is 14, there's your doubling. So I'll put a 2 here. 1990, let's make a 0 out of that, because we know what something to the 0 is, so we have control over the computation. Yep, mathematicians, control freaks. 2024 minus 1990 is 34 years. If I divide by 34, I get 1. 2 to the 1 is 2. 2 times 7, 14, plus 3, 17. All right. What's the inverse of y equals 3? X equals 3. What's the inverse of 1990 to 10? 10 to 1990. What's the inverse of 2024 to 17? 17 to 2024. Dot, dot, let me move this x equals 3. Because we are going to study the limit as x goes to 3 from the right, which means 17, 10, 9, 8, 7, 6, 5, 4, 3 and a half, 3 and a quarter, 3 and a tenth. We're going to look at table values and see what happens to this function. And we'll call this function f of x. This function right here, we'll call it f of x. We'll name it in a minute. And I'm suggesting that you're heading where? Negative infinity. Just planting a seed. Not going to ask you about what I just said there until we talk about it. All right, so what's the equation here? Y equals. Have you had enough practice with the other two to know what number comes first? If you said 1950, you're on your way to learning something. And then if you said, how do you get from 1950 to 2024? You're learning a little bit more. 19, oh, that's a 90, isn't it? What was it over here? 1990. Bad eyesight. Right? How do you get from 1990 to 2024? I guess you got to go 34 years into the future, which was the past. I don't know if that made any sense. It's a logarithm with an asymptote of x equals 3. So do you know what to write in the parentheses? I hope so. X minus 3. And then you use x's. You use them. Let's put a 10 in. 10 minus 3 is 7. Dividing by 7 gives you log 1. Said what log 1 was earlier in the video. What do you put on top of anything to get the quantity 1? The exponent 0. And these are all about exponents. And 0 times 34, they'll put a little dot there, times 34 is 0. It gets me 1990. Correlation. Oh, that's a happy smiley face. Good thing I stopped drawing the 3rd grade. All right, then we use 17. 17 minus 3 is 14 over 7, and there's our base 2. So over here, let's put a number in and guess what the next one would be. We'll end the video there. So what do you think that number is going to be? Well, it's not 21, folks. No, it's doubling. 7, 14. It's actually going to be 28. And if I add 28 to 17, I think that's 45. If I didn't make a mistake. And if I add 34 to 24, I think I'm 58. So 2058. I think we get 45. Let's find out. 2058 minus 1990. 68 divided by 34 is 2. Oh yes, we're squaring a 2, which is a 4. And 4 times 7 is, yes, that 28 units of change plus 3. 28 plus 3, what did I say, 45? That was wrong. 28 plus 3, I said something stupid before, 31. Right, but it is that ratio of change, so at least I stated that properly. So over here, 31 should get us 2058. 31 minus 3 is 28. 28 divided by 7 is 4. And what's the exponent put on top of a 2 to get a 4? 2. And 2 times 34 is 68. And 68 plus 1990 is 2058. It's like it works. So we want to get familiar with this. And that's going to take practice. It's going to take reps. And you just had a little practice. So maybe you're a little further along. We got to keep having the reps until we change all of these functions into a new notation. Coming to a theater near you. And that theater is called the end of next week. All right, so I'll upload this. You think about it, maybe play the video. Maybe spend 10 minutes here, 10 minutes there, come back to it, another day, 10 minutes, let the brain start to sort out, let the neurons start to fire. And then we're next week tackle a big topic. Ta-ta.